Good day, student. Welcome to EXQUISITE Tutorials, your best academic platform for science students, especially those offering those that want to write WAEC, those writing JAMB, those writing NECO, those in various universities, 100 level, 200 level, across various faculties and departments. Okay, JAMB is about to start. JAMB is kicking off on the 6th of May 2022, and JAMB is a major challenge to most students trying to get a high JAMB score in order to get their university of choice and course of choice, which is not really easy. But here comes EXQUISITE Tutorials. We have come to make JAMB so easy for you, and we have come up with EXQUISITE JAMB RHEMA. Now this RHEMA is going to last for just 10 days. This RHEMA will cover your chemistry, your biology, your physics, and your mathematics. So get set for the best. Now we're going to teach you ways you can blast your JAMB without struggle. The way this RHEMA is going to be now, okay, like today we are starting with chemistry. The way it's going to be is that we're going to cover the full JAMB syllabus in just 10 days. You're afraid, right? What did I say? We're going to cover the full JAMB syllabus in just 10 days. Now watch the magic. This is going to happen. We're going to cover it topic by topic across all subjects. And we're going to use we're going to explain all the topic in a way that you just get into the exam hall. Once you see your questions, you look at the answer, you click, move to the next question. Now, today, we're beginning with the chemistry, and we are taking the study of matter. Now, these questions that are here are not just past questions that we picked and gave you to study. No, these are RHEMA questions, revelations questions. These are questions that you should expect in your JAMB exam. We have so much evaluated JAMB, look into JAMB and understand the kind of questions that you should expect. Now, even if you didn't see exactly this question, you are going to see this question and we're going to answer it. Now, watch. Let's start. Now, question number 1, starting with matter. These questions will cover everything on matter. The first one say, a liquid boils when? This is a question mark. Now, point, matter talks about the states of matter. We talked about the solid, the liquid, and the gas. Now, talking about the liquid point, when do a liquid boil? This is what they are trying to ask us. Now, a liquid boils. Now, you will see options like a liquid boils when A. You see option like A, when the liquid acquires a potential energy, or it's B, you will see when the liquid acquires an energy which is the same as the average kinetic energy. You see like C, when a liquid acquires an energy, or constituents of the liquid acquire an energy as same as the average kinetic energy. Now let's explain the concept of boiling. Now let's go with the answers here. Answers. A liquid boils when the particles of the liquid acquires an energy, or acquires energy which is above the average kinetic energy. Now, in a liquid, there's what we call the average kinetic energy of that liquid. Now, that is the reason why when, let's say for example, you put a liquid on fire, a liquid like water, it will take some minutes. It's not exact minute that the liquid gets into fire that the liquid start boiling. Never. It will take some minutes for the liquid to acquire some energy. Now, from energy which is above the average kinetic energy for that liquid to boil. Until that liquid acquires an energy which is above the average kinetic energy of that liquid will not boil. So, once you see a question like this, the liquid boils when particles of the liquid acquires energy which is above the average kinetic energy, KE. So when you see a question like a liquid boils, just go straight at. In fact, don't look any other option. Once you see a liquid boils, when particles of the liquid acquires energy which is above the average kinetic energy of that liquid, click it and go. We are done with this question. Now let's go to question number 2. Pure water can be made to boil below 100 degrees Celsius under. Now, this is still on boiling point. This is still on liquid. Now, when we are talking about water, we are made to understand that the boiling point of water is at 100 degrees Celsius. Now, how will you make water to boil below 100 degrees Celsius? In your JAMB questions, you see questions like increased volume, decreased volume, increased external pressure, and decreased external pressure. Now, if you talk about volume, the volume of water does not determine its boiling point, does not determine its boiling point. Now, if you have 1 drum of water and 1 liter of water, the same time it will take 1 drum to boil, the same time it will take 1 liter to boil. So when we talk about the boiling point of water, the volume does not have anything to affect it. So the next option you are going to have is increased external pressure or decreased external pressure. Now, external pressure affects the boiling point of water. When the external pressure is increased, the boiling point of water can boil above 100 degrees Celsius. But when the external pressure is decreased, it means the water has enough internal pressure to boil. So when the external pressure is decreased, water can boil below 100 degrees Celsius. That means increase in external pressure increases the boiling point of water, then decreased in external pressure decreases the boiling point of water. So when we talk about pure water can be made to boil under, the right answer is decreased external pressure. So once you see pure water can be made to boil below 100 degrees Celsius under, just click decreased external pressure. Forget about all the other options. Move to the next question. Operation look and click. Now let's go. At the melting point, constituent of solid particles does what? What do constituent of solid particle does at melting point? Now, the melting point, before I've been talking about boiling a liquid to solid. Now we are talking about melting. You see, we are moving so fast in matters. Now we are talking about melting point. At melting point, constituent of solid particles does what? Now, what makes solid particles to melt? Now, you know that what keeps solid particles together is the attractive forces. Because the attractive forces of solid particles are strong, that's the reason why this is a solid particle. That's the reason why this marker is together and not flowing. Now, at melting point, you have so many options. Probably you have constituent of solid particles acquires energy, or constituent of solid particles acquires blah, 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 blah. Now, this is what happens at melting point. At melting point, constituent of solid particles, they vibrate vigorously. And after vibrating, they break the attractive forces which is holding them together as solid. So you will see different options in your exam. Or they may say like at melting point, constituent of solid particles acquire energy above the average kinetic energy. That is not true, because when we are talking about solid particles, we are talking about the attractive forces. So what happened is that at melting point, constituents of solid particles vibrate vigorously and overcome the attractive forces of solid. So once you see at melting point, constituents of solid, what you just look at vibrates vigorously and overcome the attractive force of the solid. Click and go. Move to the next question. Question number 4. An organic solid melts between 150 degrees Celsius and 120 degrees Celsius. This indicates, now, still on melting point. When we are talking about substances, during when they were treating you substance or states of matter, there's what we talk about pure substance and impure substances. We are made to understand that pure substance has a sharp melting point and a sharp boiling point, which is to say that pure substances, they melt or they boil at almost exactly the same point. Okay, let's say what we are trying to explain is that every pure water is going to boil at 100 degrees Celsius, irrespective of the volume, irrespective of anything. So long as it's pure, it should boil at 100. Now, if there should be a distance that it boils, it should not be less than more than 0.0 something. But once you see an organic compound or a matter that has a distance in its melting or boiling point, that indicates impurity. So when you see a question like an organic solid melts between 115 degrees Celsius, Celsius and 120 degrees Celsius, this indicates the next thing that comes to your mind is the presence of impurity. You may see different options there, you may see different options, but what is to know that it indicates the presence of impurity. That means that is an impure substance. It indicates the presence of impurities. Once you see this, click it, move to the next question. Now, question number 5. What do allotropes have in common? Allotropy is one of the most common questions in JAMB chemistry. Remember, we are still on matter. Now, what we'll call an allotrope? An allotrope of a substance is, or an allotrope of an element is an element which is occurring in different physical means. Okay, let's say for example, carbon. Carbon is an element that occurs in different physical means. Carbon can occur as graphite. It can occur as diamond. Now, what do graphite and diamond have together? What they have together is the fact that they are the same elements, which is carbon. So, what do allotropes have in common? Do they have physical properties? Do they have chemical properties? What do they have in common? What allotropes have in common? The major thing that should come to your mind when it comes to allotrope is the same chemical properties, because an allotrope of an element, irrespective of the physical state of the element, it still contains the element. So what allotropes have in common is chemical properties. That is to tell you that if you react a graphite with oxygen, or you react diamond with oxygen, it's going to give you the same reaction because they are all carbon. So allotropes have the same chemical properties. So once you see allotrope, the next thing that should come to your head that they have in common is chemical properties. Click it and move to the next question. Now, question number 6. Which of the following oxide will produce an aqueous solution with pH less than 7? Now, when we are talking about oxide, or when we are talking about, okay, first of all, let's talk about substances that has pH less than 7. In our pH scale, we are made to understand that substances below 7 are said to be acidic, above 7 are said to be basic, while at exact 7 is neutral. Now, which oxide will produce an aqueous solution with a pH less than 7? Now, at this point, once you see a question like this, they will bring in different oxide. You see oxide like copper oxide, you see something like calcium oxide, you see something like magnesium oxide, you see something like carbon oxide. What makes you to know or to understand how to answer this question or to get the right answer of the question is that oxides or of metals produce basic compound, while oxide of non-metals produce acidic compound. So whenever you see an oxide, okay, let's say for example we have these following options: copper oxide, calcium oxide, magnesium oxide, and carbon oxide. Now, copper, calcium, magnesium, these are metals. So definitely these three will give us a basic compound. So that means that it will give us a basic solution. So that means that the only oxide that will give us an acidic solution is carbon oxide, because carbon is a non-metal. So that means we are indirectly saying that carbon will give us a solution with a pH less than 7. So whenever you see questions like this, what comes to your mind is, where is a non-metallic oxide? An oxide of a non-metal. Click it and go to the next question. Now, that is for question 6. Question number 7. Which of the following oxide is amphoteric? Now, we are still on oxide. Question always still comes out from oxide. Now we have metallic oxide, non-metallic oxide, and amphoteric oxide. Now, metallic oxide are oxide of metals. Metallic oxide reacts with non-metals, and non-metallic oxide reacts with metals. But amphoteric oxide are those oxides that can react with both metals and non-metals. What did I say? Amphoteric oxide react with both metals and non-metals. And one major example, number 7, of amphoteric oxide is aluminium oxide. Aluminium oxide. We have so many major examples of amphoteric oxide, but aluminium oxide is a major example of amphoteric oxide. So once you see all amphoteric oxide, click it and move to the next option. Now let's check what's the last option here. Question number 8. All the following allotropes cannot conduct electricity except. Now this question, the options there, we have rhombic sulfur, we have graphite, and we have diamond and the rest. Now, when it comes to allotrope, it is not all elements that has allotropes. I think we'll have allotropes of hydrogen. We'll have the hydrogen, we have the deuterium, we have the tritium. For carbon, we have graphite and diamond. Sulfur, we have rhombic sulfur and the rest. Now, this question most times is a way of differentiating graphite from diamond. Note, among the two allotropes of carbon, graphite and diamond, the only one that conducts electricity is graphite. The only one that conducts electricity is graphite. So most times when they're asking you this question, they are asking you to differentiate between graphite and diamond. Because graphite have free mobile electrons, so they conduct electricity. So once you see your options and you are seeing graphite, just click on graphite and you move. Now, let's move over to other questions and probably move over to other topics in chemistry. Okay, now let's continue. Bronze, question number 9. We did question 1 to 8 before. Question number 9. Bronze is an alloy of what? Okay, now let's talk about alloys and their constituents. Okay, let's answer this first. Answers. Number 9. Let's answer this first. Bronze is an alloy of what? Bronze is an alloy of copper and tin. Copper and tin. Now let's talk about, from here, let's talk about alloys and their constituents. We have so many alloys that comes out in chemistry, in JAMB chemistry. Okay, this is for bronze. How about brass? Let's treat alloys. Brass is an alloy of copper as well. Copper and zinc. Then the next alloy that comes out is duralumin. Duralumin. Duralumin is an alloy of aluminium magnesium, manganese, and copper. Now, you can still see something like amalgam. Now, whenever you see anything like this, amalgam, just know that amalgam contains, it's talking about mercury. So when you see sodium amalgam, it's talking about an alloy of sodium and mercury. When you see anything amalgam, is an alloy of the substance and mercury. So number 9, bronze is an alloy of copper and tin. Note this, bronze and brass. Bronze is tin, copper. Brass is zinc, copper. Duralumin, aluminium, magnesium, manganese, and copper. Should I clean here? Okay, number 10. A substance commonly used in drying ammonia gas is what? The substance commonly used in drying ammonia gas is quicklime. What is quicklime? Calcium oxide. So when you talk about drying of ammonia, the next thing that comes to your mind is quicklime, calcium oxide. The reason because most substances cannot dry ammonia gas due to the fact that ammonia will react with them. Now let's go to number 11. A compound that absorbs moisture from the atmosphere and eventually forms a solution is what? Okay, I will answer this question and I will use it to explain 3 things to us in this question. Okay, the substance that absorbs moisture from the environment and turns into solution is a deliquescent substance. Deliquescent. Now, let's talk about deliquescent, efflorescent, and hygroscopic compound. Deliquescent. Efflorescent. Then hygroscopic. Okay, deliquescent substance is a substance that, when exposed to the environment, they absorb moisture and turns into solution. That is a deliquescent substance. An example of a deliquescent substance is calcium chloride. known as your common salt. When you keep them in your environment, okay, that is the reason why when you expose your salt to the environment, when you touch it, you feel some kind of moist solution from the salt. That is to show you that your salt, which is calcium chloride, is a deliquescent substance. How about efflorescent? Efflorescent substances are substances that, when exposed to the atmosphere, they give out their water of crystallization. And note, whenever you see, okay, let's say they give you an example of an efflorescent compound, they didn't give, and they started writing the names of, they're writing the compound without mentioning their name. One thing you should know about an efflorescent compound is that an efflorescent compound must contain water, which is the water of crystallization that they give out. So, okay, let's say something like MO410H2O. This is how you know an efflorescent compound. They always have water of crystallization. So this is what they give out when they're exposed to environment. How about hygroscopic? A hygroscopic compound is just like a deliquescent compound, but a hygroscopic compound, when exposed to the environment, absorbs moisture but do not form a solution. So that means that all deliquescent compounds, all compounds that absorb moisture, are hygroscopic compounds, but not all hygroscopic compounds are deliquescent compound, because this one absorbs moisture generally, but this one is a type of hygroscopic compound that absorbs moisture but forms into a solution. Now let's move further. Number 12. The scattering of a beam of light in a gel is called what? Now, I decided to bring out this question because this is one of the most common questions in JAMB chemistry. The scattering of a beam of light in a gel or a colloid. Colloidal substances are substances that can scatter light rays. Colloids or gels, they can scatter, colloid can scatter light rays. Okay, one difference between a colloidal substance and a suspension, let me bring this in, is that colloidal substance scatter light rays while suspensions do not. So the scattering of a beam of light in a gel or a colloid is called what we know as Tyndall effect. So whenever you see scattering of light rays, whenever you see scattering of light rays or scattering of a beam of light in a colloid, just know that they are talking about Tyndall effect. Click it, move to the next option. Number 13. Ammonium chloride can be separated from an impure source by. Now this one is talking about separation techniques. We have different techniques of separation for separating different substances due to how they are formed. Okay, let's say for example, let's say two solid substances which do not mix together can be separated through sieving. Now, what is sieving? Sieving is a process of separating solid substances whereby their particles are different in size. So when we talk about sieving, the difference there is the size. Okay, let's say, just say for example, your gari. I don't know if those of you that have been able to sieve gari, you discover that after sieving, the big particles are up while the smaller particles are down. That's an example of separating solid substances. Now, we also have a way of separating miscible liquids which have almost the same boiling point, and a way of separating miscible liquid which have different boiling points. Should I write this? Okay, I think I should. Number 13. Okay, let's answer the question first. Ammonium chloride can be separated from an impure source by sublimation. 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 Now, first of all, let's explain sublimation before we explain anything. Sublimation is a process whereby a substance moves from the solid state straight into the gaseous state without passing through the liquid state. So whenever you are separating a substance that sublimes, they move straight to the gaseous state. So once you heat, instead of going to the liquid state, they go to the gaseous state. Any other substance there will be at the liquid state. So by then, it is easier to separate substances that sublime. An example of substances that sublime, we have iodine. Iodine is one of them. Okay, we started with ammonium chloride. Okay, let's continue. Substances that sublime. A, ammonium chloride. Ammonium chloride. B, iodine. C, dry ice. Now, what is called dry ice? Dry ice is the same thing as carbon dioxide, CO2. These are dry ice. So you can either call it dry ice or carbon dioxide. So whenever they are talking about substances that sublime and you see dry ice, carbon dioxide, iodine, so know that they are talking about sublimation. Now, the major separation technique to separate any of these substances from their constituents or from any solution is through sublimation. Okay, let's talk about other separation techniques. Okay, let's take question number 14 first to talk about other separation techniques. We have immiscible liquid can be separated by number 14. What are immiscible liquid? Immiscible liquid are liquids which did not mix together. By the time you add them together, one will be at the top, one will be at the down. Okay, kerosene and water are two immiscible liquids. So the major way of separating two immiscible liquids is by a process known as filtration. Filtration is the way of separating immiscible liquids. So let's talk about other separation techniques. Now, the criteria or what is used to differentiate substances that sublime from another is their ability to sublime. Now here we'll talk about filtration. Filtration talks about immiscible liquid, miscibility. Now let's talk about, I think earlier I talked about sieving. Sieving is used to separate solid with different size with different particle sizes. Sieving, solid plus solid. The difference is the size of the particle. And another we talked about earlier, I was talking about substances with miscible liquid with different boiling points, with distance boiling point and close boiling point. Now to separate miscible liquid with which have distance in their differences in their boiling point, you use distillation. But those that have a close boiling point, you use fractional distillation. And fractional distillation is what we use to separate constituents of petroleum, or let's say constituents of crude oil. Which other? Evaporation is what is used to separate a solid, a miscible solid from its solution. An example of that is separation of salt from water. The water evaporates while the salt remains. Which other separation techniques? Chromatography, talking about absorbent material. So your ink the ink of your pen can be separated by chromatography. And what have other separation techniques like decantation? What have other separation techniques like crystallization, fractional crystallization, and the rest? But the most common where they ask question is your filtration, immiscible compound, sublimation, and we also talk about distillation and fractional distillation and chromatography, separation of separation that involves absorbent of materials. So with this, we are done with the first topic on chemistry, who talks about matter, states of matter, separation techniques, boiling point, melting point, pure and impure substances, and we have talked about alloys of substances. We have talked about oxide, we have talked about acidic oxide, basic oxide, neutral oxide, we have talked about pH, and we have talked about a whole lot on this first video on chemistry. You see, it's a vibe to be here and it's a nice thing to be here. Watch out for the next episode of JAMB RHEMA with Exquisite Chemistry. And don't forget, subscribe. Turn up your notification because in these 10 days, you're getting all you need to pass your JAMB. It's still Exquisite Tutorials and I will tell you my name. Have a nice day.